Hello everyone. Today we will be talking about sentiment analysis and automatic classification, which is a wider category to which sentiment analysis typically is understood as belonging. We'll be working in Python, and there are Jupyter notebooks that you can link to accompany. You can follow along as I'm working, or in fact, you can just review them later if you prefer. You can maybe just watch this demo, go back on your own in your own time and work through it. I have posted the link in the chat, but you can also see it here at the top of my browser window. So I'm going to go to this web page and show you what it looks like when Binder is launched and you can access the Jupyter Notebook through the virtual environment created in your browser window by Binder. And then I'll actually go to a Jupyter Notebook that I've hosted on my own computer, because that will be more reliable for speed. Just because I don't know how many of you are going to, go launch the Jupyter Notebooks yourself, and then, that could create a lot of traffic and slow it down. And I don't want to slow down the live coding stream. So when you go to that page, it then launches a virtual environment. You can see here, it's within mybinder.org. And you can see these are the different Jupyter notebooks that we have available for the text mining training series. Today we're doing classifiers. Last time we did basic extraction, and the first was basic processing. So what it does is it launches this Jupyter Notebook in the browser window. This is a virtual environment. What you can do is double click in the code cells. They're marked this way with a little sort of you can see visually they're distinct. Double click in them and either hit run button at the top, or you can hold down the shift key and click enter. And then they will. That's not actually my name. My name is not Julia Gulia. But it's amusing. So anyway, what they do when you, within the Jupyter Notebook virtual environment in your browser, double click in the code cells and either hit the run button or hold down the shift and hit enter, and that runs the code within that virtual environment. So you can do that on your own. Again, I have posted the link in the chat window for this live stream. But I'm going to close these down because I don't want to overload them. So now I'm running that same Jupyter Notebook, but on my local host, because this will be more reliable. Right, so let's get into it. Although, looking over, I can see I've got a few viewers. Please let me know if you can hear me, or if there's any problem like that, and I will get into it. Sentiment analysis is one of the most popular kinds of automatic classification. What that means essentially is training an AI or a learning algorithm to identify all the features within text that are passed to it, and use those features to determine, is it likely to be category 1 or category 2, or you could have a large number of categories, but often it's either binary or there's only 3 categories. Sentiment analysis is doing that kind of classification based on typically things like, is it positive or is it negative, with the option that they can also be neutral sometimes. So to get started, the first code cell imports a few useful Python packages and also lets us know, what file we have to work on, and installs a few other things. Text blob is the key feature for us today, because text blob is the package that we're using to do our sentiment analysis, our automatic classification. Now, let's this is still running. You can tell because it has a star there, but it is now progressing through. So this is just it's printing out that we have options, testing set and training set. I'll get into that a little bit more before too long. So let me say a little bit about how the AI or the learning algorithm learns. What it does is you train it on a training set, and that is a set of documents, each of which has a clear category or sentiment or whatever kind of classification that you want the computer to learn to assign text like that to. Let's look at some text examples here. We can import doc1, doc2, and doc3. And they are quite trivial things. They say things like, text blob is just super, I love it. Cabbages are the worst, say no to cabbages. Paris is the capital of France. Deliberately, I have one that is positive, one that is negative, and one that is neutral. You are probably not surprised by that. So what these do is, because they are clearly positive, negative, and neutral, I can use a pre-existing built-in sentiment analysis tool to tell me for document 1, what is the sentiment? For document 2, what is the sentiment? For document 3, what is the second sentiment? So let's see what that gets us. Okay, so polarity, this is 0.479, let's say. So it is positive, pretty positive. You know, it's at least halfway up to absolutely totally positive. For document 2, on the other hand, it is -1, which is just about the worst you can get. And unsurprisingly, Paris is the capital of France, comes out as polarity 0. So you can see there's assorting things between positive, between just above 0 and 1, negative, between just below 0 and 1 and 0. Now this is using a built-in sentiment analysis that comes as part of text blob. You can, of course, there are others available, but certainly for getting started, that's an easy one to use. Okay, you can, if you're following along in your own Jupyter notebook, feel free to add more documents or to change these documents and then rerun these 2 code blocks to see if you can get something that is more positive or something that is less negative. You know, maybe you want to say something like, text blob is just the absolute best thing I've ever seen. It is greater than bubbles in champagne, whatever you want to say. So play around with that. I mean, just as a first go, that's an easy one to play around with. Now, let's have a look at this. What this does is it prints just the sentiment polarity, and this is just the sentiment subjectivity. Subjectivity, by the way, is like sort of how confident it is in that polarity judgment. So maybe instead of both of these numbers, maybe you don't care about subjectivity, you just want polarity. So you can get that by sentiment.polarity, or you can get just subjectivity here. Now, those were quite trivial documents that we were analyzing. You won't be surprised. They were super trivial. But we can do something that is more interesting. And for that, I have the training set that I showed you at the beginning. So we're going to open that and load it into document set. And then we're going to print a subsection of document set. Now, in this case, it's a training set, which means it not only contains the material that you want to analyze, but it also contains a judgment about its polarity. So in this case, for this particular document set that I downloaded from the web, they come in 0, 4, and -4, which just gives a wider range. But just like the first documents I was looking at. It's either very positive, neutral, or very negative. Okay. Apologize if there is some foul or negative language in this, because this is a training set that you can download. A lot of researchers have used it. I believe it's based off of reviews for products on Amazon, so there are going to be some completely irrelevant material in there and also some quite colorful language. Okay, so each object in this document set has a list containing first a string and then a number. That's all you need for a training set. So what we're going to do now is edit the code above so that docSetAnalyzed only has the text string, not the number string, or the, so it doesn't have the polarity. So essentially we're creating a new set of documents that only contains the text string, leaves out the number. Looking at it again, doesn't look like it works quite. Oh no, sorry. It inserts the sentiment as well. So we're going to analyze that document set using our text blob built-in sentiment analyzer, and following the analysis, the polarity that was given in the training set, we're going to append the polarity that the sentiment analyzer thinks is the correct sentiment for this. So you can see there's a little bit of a mismatch here. This sentence is supposed to be neutral according to our training set, but our sentiment analyzer suggests it's quite positive. Actually, it's nearly half. It's not an insignificant positive. Here also supposed to be neutral, comes out as 0.23, so this one's a bit positive, but not too far off neutral. And you can go through all the different ones and find how they do. But we can compare those in terms of accuracy. So we obviously see that the training set comes with pure negatives, positives, and neutrals, whereas the polarity suggested by the sentiment analyzer comes out with some, probably this, and it's a bit like that, and okay. But we can compare those and we can see the accuracy. And because the training set we used has positives and negatives going out to 4 and -4, whereas the sentiment analyzer that comes with text blob has between 1 and -1. So we need to do a little bit of fiddling there, replace the things, and then compare the accuracy. So there's this extra step here where it's sort of, if the item, if this item in the list is a 4, turn it into a 1. If it's a 2, turn it into the. So we can run this code. It transforms, sort of standardizes the two different polarity statements. Oops. Maybe have I skipped something? I have no idea why that's decided it doesn't want to work. Let's see. Unsupported types for int, and so it's I must have not loaded a package for recognizing absolute numbers, perhaps. That seems bonkers, but all right. Well, hopefully it works better in your version, the version that's hung up through Binder. Now, if they were in, you can then compare the output, so you can compare the accuracy. And we're not expecting it to be perfect, of course, because it isn't. Let's try this one, see if, again. Oh, it's not recognizing the greater than symbol, that's the problem. At least that's the problem here. Not supported. Okay. I should have tested this. Never fails, does it? So hopefully, if the version that you have through Binder is working correctly, no problems. Otherwise, I will correct it and load a new version as soon as possible. But if you understand the basic concepts of how you would go about comparing the accuracy, then we can leave that out for now. What you're probably interested in is training and testing a sentiment analysis tool. Now, we can provide our own training data that we have decided, how it's classified. So you don't have to use numbers. You can use pause and neg, as I've done here. And you can put your own data in. So this allows you, for example, if you are working with a very specific kind of language, maybe complaints made to the police department, or suggestions made on surveys, the free text entry field on surveys on a particular topic, then general language sentiment analysis probably won't be very accurate for your purposes. And the key there is to manually classify a subset of your data, train a sentiment analysis sort of learning algorithm, and get it to analyze the rest of your data. Okay, so in this case, we will run this code. And that's quite good. So I've created two little variables here, train and test. They look the same in that they both contain a sentence, a comma, and then either pause or neg. But the items in train are not present in test. So that way it really has to learn what features of these sentences lead it to be positive or negative, and then it tries to apply what it's learned to these new materials. Okay, so what this does is it is defining a brand of this data set, the train data set. So with just one little line of code, I have trained a classifier on this custom data set. That's quite fast, actually. So let's see what we can do with it. Now, I've fed it the words, I have created the output that it is probably positive, because its positive score is 6.63 and its negative score is 0.37. So what you can see here is that the probability distance max, and then the probability of its distance to positive, and the probability of its distance to negative. So essentially I'm saying overall it's 0.63, because the things that the computer thinks are positive about it come to, overall it's positive, because the things the computer thinks are positive about it are worth 0.63 points, I guess. And the things the computer thinks are negative about it are worth 0.37 points. So on the whole, it's positive. Now, if we want to apply it to multiple sentences, rather than one at a time, feed it, this is an amazing library, or this one is a doozy, we can do that too. So let's run this next code block. Okay, so on here we've run text blob on these sentences with our classifier, a custom classifier. We've stored the output of that in a variable called blob. And we're printing overall the output of running that classifier on these sentences is positive, because the sentences are, the first one is positive, the second one is negative. We can presume then, because the whole thing is positive, that this one is more positive than that one is negative. Seems a bit abstract to me, but all right. Right, so now let's try this one's designed to produce an error. And that, yep. And it's because we have not provided it with a classifier. And in fact, this time, the difference between this code block and this code block is that we have provided it with our custom classifier. So this time, classification of document 1 is passing this, which was the context of document 1, through this classifier according to this package. And then we'll print the output. So let's see what we get. Positive. Unsurprising. Text blob is just super. I love it. Comes out as positive. Now that was true originally with the sentiment analysis, the sentiment analyzer that came built into text blob, but it is also true, the sentiment analyzer that I have trained myself. So let's try an accuracy. So if we were to run, what this does is this time by running my classifier accuracy on test, that is using the test data that I defined here rather than the training data. Now, my custom classifier has not seen this this data before. It only saw this. But based on what it learned about this, it is now analyzing this, and it does so with an accuracy of 0.833. And it knows it does so because in the test data, I do feed it the right answer. So I ask it to predict what the right answer will be, and then I tell it the right answer. I ask it to keep track of how often it got it correct. It's a bit like marking your own homework. So it's not perfect, and we can add more data to our existing classifier. So we don't have to train a whole new one. We can just feed it some new information and see if that improves its accuracy. So the new information here, things like, just 4 more sentences. I update, use classifier, that's my custom classifier. .update is the command to update it using new data. And it says, yep, I've done that. So now, I can just rerun this rather than copy paste. The copy paste is more so that you get used to copying paste. And look, now it's got a perfect score. It knows exactly how to classify the kinds of sentences I'm feeding it in test according to the information I've given it in its training data, 2 phases of training data. Now, I was feeding this, you will not be surprised to see, quite basic data. You can give it more interesting data. And, we do have the training set and test set from before, those downloaded from the Amazon product review comments. So let's just have a quick look and see. Actually, there are 20,000 of these comments. That is definitely not a trivial amount of comments that are already pre-classified as positive or negative or neutral. But maybe that's actually a bit too much for me. It's certainly to do in this sort of live demo where you want the results within, maybe a minute at most you want to wait. If you're doing something really complicated on a major research project, you can, of course, set your classifier to train itself overnight and come back in the morning. So 20,000 statements would not be a problem at all. Or even over the weekend or, over the course of a week, or you could put it on a big server if you have a research IT department that can help you do that. But for the purposes of our work, we're going to use just subsets of that data. So you won't necessarily want to use the whole set. You can download things that are millions of statements long. They come pre-analyzed as positive or negative, or anything that you want, So let's run this code. And you can see a different subset of, this is the testing set. And, we can see it's a bit different than the training set. So that allows you to run your accuracy tests and sort of judge your output, really. And this time, to do an accuracy, you don't have to change it because both the training and test sets, are both in the same format, the 2, 4, and 0. So, just take a quick break before we discuss anything further. Do you have any questions about training sets or test sets, classifiers? I'm happy to talk about maybe some areas that you might want to use this kind of method in your own research. Give it a moment. There's always a bit of a lag on these live streams, maybe about 20 seconds, I think, as far as I can figure it out, although that's probably subject to a lot of variables, like who else in my house is using the internet at the moment. So I wanted to talk about a few other things. We could, for example, you could classify political statements made to, the House of Commons or the US, House of Representatives or something like that. You could classify them by the political party of the person who made the statement and then try and predict whether a statement that is not known for political party, which political party is likely to have said it. That'd be an interesting use of classifiers. Do you have a question? Adam asks, how good have you found the inbuilt classifiers are? I have found them to be good, but quite limited. That is, they are really only good for looking at fairly bland, basic kind of language, because they tend to all use bland, basic kind of training data. So the one that comes built in with TextBlob, for example, has a lot of statements that people make, the kind of statements I used here in my training and test. These things like, I love this sandwich, and this is my best work, and he is my sworn enemy. These, all right, maybe that one's not terribly bland. They are not good at the kind of real world text that people use when speaking, or when speaking to people that they share a lot of context with. So, for example, the chatter in a friend's WhatsApp group is going to be very hard to classify using a classifier trained by these kinds of sentences, because people don't speak in these kinds of sentences to their friends in a familiar context. In that case, you would probably want to train your own classifier, but really it's not very difficult to train your own classifier. The difficult part is getting test and training data sets set up and sort of manually classified. Although, of course, you can manually classify a small set, use that to train, use that to suggest manual classifications for a larger set, and then it's much easier for you to manually go back through and review the suggestion rather than create the suggestion in the first place. So you can sort of use it to build outwards an increasingly large manual sort of a training set. Now, they inbuilt classifiers are of absolutely no good on topics that they are no created training and test data sets for. So, for example, when I talked about statements made to the House of Commons or the House of Representatives, if we classified those by the political party of the person making the statement, to my knowledge, that test and training data set are not available. They certainly could be made quite easily, because statements tend to come with things like, this person, parentheses, Democrat, Ohio, or something like that. Or, this person, Labour Party. These kinds of things tend to be labelled, at least in newspaper articles, so you could fairly easily create those training and test data sets. But you would have to do it for yourself. Okay, got another question. Does this analysis cope with irony and subtleties, or are these dismissed as noise in big volumes of data? Irony and subtleties are definitely things that you could train a classifier to deal with. But at the moment, certainly built-in sort of analyzers are not good at dealing with them. I did at one point start building a sarcasm detector to put on Twitter. And I got somewhere, but the accuracy wasn't great, because there's just so much sort of subtle context and new information that comes into irony and sarcasm. That isn't to say it isn't worth doing the research. It's just that me playing around with something in my spare time, I was not able to get very far with it. I was able to get somewhere with it. So it is certainly, if it's a question you want to research, then it can be done. It certainly, you can make good first steps into it, because I don't know that anyone has really done that in a scientific research context. It would be good, for example, to know if you wanted to use a sentiment analysis or automatic classifier to recognize when people are maybe making dog whistle statements or sarcasm, and then they later claim that they make a statement and they later claim it's sarcastic. Actually at the time, was it likely to be interpreted as sarcasm? Something like that. So, irony and subtleties are they really complicate the issue, but that doesn't mean that sufficiently large training and test data sets can't overcome those complications. That's a really good question. Thanks for that. Any other questions? Oh, just to be clear, you can do this in any language. And as I said, you can have the categories they can be many different kinds of categories. So you could, try and classify scientific abstracts into scientific disciplines. So you would have things like biology and physics and chemistry and psychology or whatever else. You could have binary distinctions like positive, pos, and neg, like I've got here on the screen. You could have numerical categories like 1, 0, and -1. There's a lot of options. You can do them by language, multiple categories, whatever. The more categories you have, the more training data you need. That is an interesting, there's not, as far as I know, a good fixed ratio of how many examples of each category you need. But I would think a good rule of thumb would be at least a couple hundred to get started with. And then you can test your accuracy, and you can, sort of evaluate whether one of the categories is actually much harder to classify than the others. If psychology talks about a lot of different kinds of concepts, whereas physics, all physics papers tend to have equations in them. it's going to be easier to classify physics than it is psychology. So, you have to think about if there's a really easy sort of signpost that says, yep, this is category A, then you don't need as much category A training data, at least relative to your category B, if category B is much harder to recognize, much more nebulous, much more hand-wavy, timey-wimey stuff. All right. We have plenty of time if someone wants to suggest some other questions that I can cover, or if you have other questions about classification or how they're trained or how they're tested, how the data sets are created. So, for example, you might something that you might be able to do quite easily, just with data you already have. Maybe if you already have survey data, you might train a classifier to predict the gender or the age group or something or other, some feature that you have recorded for your results, and then see, it's kind of another way of finding correlations between independent variables and dependent variables. Yeah, that's a good question, Michael. How do we validate or apply reality checks? Surely we don't need another black box. Validating is a matter of running good tests on a test data set. So you will get things, not only the accuracy sort of number that I applied earlier, this accuracy test, but you can get things like there's a few different kinds of accuracy. So you can say the number of things that your classifier incorrectly included in a category, the number of things that it incorrectly left out of a category, and then the number of either kind of error overall. So there's different kinds of things, and which of those kinds of accuracy matters to your reasons for automatic classification. So if you are using automatic classification, for example, to determine whether or not a piece of text is likely to contain some kind of suggestion of criminal activity, you might not care very much about false inclusions, because that is the kind of result that will be passed to professionals, detectives or something like that, who will review that that result quite closely. So they will expect, right, here's 100 suggestions of possible crimes. I'll read through these comments and see, actually, is anyone planning a crime, or are people just being silly, or are they just being confused or using language loosely? On the other hand, so in that case, a certain kind of wrongness, not a problem. You want everything that might be talking about crime. Whereas if you want to, if you're analyzing images, for example, instead of text, you don't necessarily want every single possible image that might be a sign of, a cancer or something like that. You want the in that case, the automatic classification should have a really fine-tuned accuracy for, no, this is likely to be cancerous, it needs more investigation, as this is likely, it might be cancer, but it's likely to be a cyst, and therefore, not a priority. Because in that case, the risk of problems associated with a false positive is quite serious. There are real health implications for being told you need further study, further investigations, when in fact it's obviously a cyst, but the computer doesn't know obvious. Beyond that, the question of do we need another black box is you should never rely on automatic classification for all of your answers. It is a tool to help you identify things over the kind of scales that you would not be able to identify things yourself. So you can use it as a first step in identifying things that need proper human attention, or it is a first step in saying, we think we see a pattern here, let's look closer, let's look at these other features, let's look at this and that and the other. It is a helpful suggestion from a computer which can be understood as clever in some ways and stupid in other ways. So it is a black box. It is very, very clearly a black box. So you should never use it alone. But black boxes are still very useful if the other option is not doing the work at all, because sometimes there is just too much work to be done by hand. Okay, and Catherine asks, can you assess accuracy by specific features of the data? For example, physics papers from the US being easier to classify versus those from UK. Yes, when we address up here where I talked about polarity and subjectivity. Polarity in this case is its suggestion for is this positive or is this negative, and subjectivity is its confidence on, how confident is it in that positive or negative sort of determination. And you certainly can apply statistical analysis to, there are other things you can look at besides subjectivity, and you can look at the text blob documentation to find out exactly, but you can pay attention to subjectivity and identify which ones are harder to classify and sort of what are the features of those exactly. That's a little bit why it's a bit of a black box, in that there are ways to tease it apart. So you could give it an abstract that, you could identify two abstracts, ask a US academic to rewrite it in his own words and a UK academic to rewrite it in their own words, and then give it to the sentiment analyzer and see, is one harder to classify than the other? Is one come out as more easily classifiable or more confidently classifiable? You could do those things. It is not large features of the people who write the text will not be present in the text. So let me put that another way. If everyone from the US is likely to use certain spelling, for example, and a learning algorithm could possibly learn that if you spell your words this way, you are more likely to be a physics. You're more likely to write in physics or something like that. You're more likely to belong to this category, that category. But those features are so diverse and widespread across the population of writers that it would be very difficult to say exactly what it was about a particular way of spelling a word that makes it more likely to belong to one category or another. Besides which, US and UK writers can belong to any scientific discipline. So there are ways to tease it apart a bit. You can say the learning algorithm is likely to, certainly if it's trained on US style writing, it is likely to find US style writing much easier to understand and classify because that's closer to its training material. But that doesn't necessarily mean that it will really say, oh, it spells this word that way, therefore this belongs in that category. Yeah, that's a good one. I mean, that reflects back a little bit on the issue of like how close your training data is to the data that you want to apply the classifier to. Your training data should be a representative sample of your total data set, if that makes sense. So we don't want to train a classifier on a set of documents that are 50% positive, 50% negative, and then, expect it to be very good at picking out the subtleties of very positive against very negative, or something like that. You want, let me say that a better way. If you were training a document classifier on mostly physics papers, some biology papers, and some psychology papers, it would be really terrible at recognizing biochemistry papers, because that didn't feature at all in its training data. And it would be less good at psychology if most of its training data was physics. Hopefully that helps. I realize I've waffled on terribly and used terrible grammar. I apologize. It's coming up on 5 o'clock and it has been a day full of meetings. But do ask me any other questions if you like. Of course, in this case, I'm talking about text analysis, sort of classifying strings of text, but you could classify whole documents, you could classify images, you could classify video, you could classify, I don't know, body postures, like anything that you can create a training set and a test set for that you could manually classify. Those things could be fed to a learning algorithm for automatic classification. And we live in a world where there's loads of text available, so text is not only readily available to use, but also overwhelmingly voluminous in terms of like what we want to do with it. We definitely don't want to manually go through 20,000 product reviews and say positive, negative, this is sarcastic, that's not, this is a conservative thing to say, that's a liberal thing to say. You kind of want sources of data that do some of that for you, but also the sheer volume that makes it hard to do manually means it can be quite interesting. You can really uncover some unexpected sort of outcomes. All right, I'll give you another chance for asking questions, and if nobody wants anything else in the next 30 seconds to a minute, then I will let you go. Enjoy your afternoons, unless you're in a different time zone, and then enjoy your appropriate time zone. Let me know. It's quite off-putting. I can see an image of what you're seeing, but with the delay, and so I can see an image of myself chattering, but with a delay. And it's Any advice on working with Twitter data? Well, I think the trick with Twitter data is to get it out of Twitter data first, and then using the Twitter API is not straightforward, but we do have Jupyter notebooks and code demos about that, so you can search our UKDS YouTube channel for those videos if you're interested in learning more about Twitter APIs. It would depend on what you wanted to do with the Twitter data. So if you want to, classify it by what kind of hashtags it's likely to have. So you could strip out the hashtags from the tweet and have those as the categories that the tweet belongs to. And then you could, give it could learn which hashtags are associated with which kinds of tweets, which kinds of sentences, and what kinds of topics and styles of writing and things like that. And then you could use that to create a sort of hashtag suggestion tool. But yeah, if you wanted to the tweets into, sarcasm would certainly be an interesting one. The police, sort of law enforcement agencies certainly do have AI algorithms reviewing the social media feeds for people that they think might be criminals because they're looking for evidence of criminal activity. I don't know. That might be an interesting one to do with the political parties, because you could look at the Twitter feeds for sitting members of parliament or sitting, congressmen, and try and see the topics that they talk about are more likely to be talked about by one political party or another, and analyze whether the way that some member of the public talks about that topic is more like the way political party A talks about it or political party B talks about it. That would certainly be an interesting kind of experiment. But yeah, I think the advice on working with Twitter data is that you should spend a lot of time making sure that you get your API process correct so that you can get the data, for example. But yeah, beyond that, it's it's pretty straightforward. You would just use the same as I've done here. So you would, put it into your text documents and then train the classifier on those text documents and test it on a test set and see what you can get, see what kind of outcome. All right, I think I will wrap it up then. I think we're here nearly an hour, and that's a long time to be talking about automatic classification. Yes, you can access the previous videos. They are on the UK Data Service YouTube channel. We have videos on cleaning, sort of the first stages of text mining, so preparing your texts and then basic extraction. Previous series include things on scraping data from the web or getting data through APIs. And I think we also have a video on manipulating JSON files. So yeah, there's a lot of resources there for if you're interested in all of the different steps associated with doing a sentiment analysis or automatic classification on Twitter data. Although it might take you a while to watch all of those videos and implement all the things they have. But yeah, we also have the Jupyter code notebooks that will provide code that you can use to achieve those steps. So yes, absolutely. Happy to see you using all of the different resources we have, the code notebooks, the past videos, and come back next week. I will be doing another one of these text mining code demos on automatic entity extraction and social network building. So I'll be using text mining methods to extract all the named entities from a body of text and then build relationships. So create a social network between those entities based on whether they co-occur in a sentence or not. Right. Thank you very much. Have a lovely day. I will see you next week.